Hi guys, good afternoon. So in the last session, we saw about EIGRP stop. We saw about the SI query and reply, and also we saw about offset list, right? That we can increase the metric using the offset list. Now today we'll start with the OSPF. So I'll create a new pin file for this. Okay, so what do you know about OSPF? Mhm. 10. Okay. Uses two multicast addresses, 5 and 6. What else? Hmm? Area based open standard protocol. Hmm? The extra algorithm. Hmm? Protocol number is 89. EIGRP protocol number is. Okay. Protocol number EIGRP is 88. OSPF is. Then what else? Hmm? Is it cost, right? Metric is cost, not bandwidth. Uses area concept. Other than that, anything else? Classless protocol supports VLSM and CADR. Then hmm? Supports MD5 authentication. What about HMAC? Does it support HMAC also? I think I gave you some task yesterday, if I remember. No task. Maybe some other batch. Yes, you were telling something. Okay. Okay. Stands for shortest path first. Why the name is open shortest path first? Hmm. Can you give me a practical example of dice algorithm? Hmm? If you think OSPF will take shortest path, according to shortest path, don't you think hop count should come in picture? Bandwidth is giving you shortest path or fastest path? Hmm? Then Google Maps works on the same Dijkstra algorithm. That's why when you search for it, if there is traffic, Google will not suggest you that path. It will show you an alternate path. Shortest but fastest. It will give you shortest but fastest. If the shortest path is Busy, congestion is there, changed. Okay, like that. Clear? If there is low bandwidth, we will not use the path. We do not prefer the path. Understood? So even Google Maps also works on the same concept. Clear? Now, why the name of this protocol is open shortest path first? Reason number one, open standard protocol. So open comes from the open standard. And shortest path first, SPF, comes from that algorithm. Okay. So uses I think you can check the spellings. So the open comes from here and SPF comes from here. And this is the reason it is OSPF. Clear? Now, your OSPF, it is a classless protocol. OSPF is a classless routing protocol. So you can say it is classless routing protocol. So when I say classless routing protocol, that means it supports VLSM and CIDM. Clear? Then after it is a link state routing protocol. It is a link state routing protocol. That means it prefers bandwidth over distance. Okay. Then OSPF uses protocol number 89. OSPF uses protocol number 89. Okay. Then AD value of OSPF is 110. What else? OSPF uses two multicast addresses. Okay. Two multicast addresses. Number one, 224.0.0.5, which is for DR and BDR. And oh yes, sorry. This one is for all. No problem. Next. For all OSPF routers and 224.0.0.6 for DR and BDR. Okay. Then anything else? Authentication also I think supports HMAC, right? So then authentication is supported. That is it. Okay. OSPF works on area concept. Now, what is an area? Group of routers. Then what is administrative system? Group of routers only. Difference? Why? Why OSPF divides an autonomous system into group of routers or areas? So that is completely dependent on bandwidth and cost. So, so what do you mean? What is least? AD? Then what is an area? Tell me. Area. What is an area? Dividing an autonomous system into multiple parts. Why? For no reason. To decrease link state advertisements. Don't you think because of the areas we have more number of LSs? If you have only single area, you have two types of LSA. Now, because of multi-area, you have to study 7 types of LSA. And every area will have their own type 1 and type 2. Then additional LSAs will also be flooded. Why? Think about it. Huh? Hmm? Why we are grouping those routers? The logical group of routers is also autonomous system. Number one, automatically your database information is reduced. Number one. Number two, for faster conversions. Why? Because routers in an area, like one autonomous system can have thousands of routers. There can be 100 routers, there can be 1,000 routers in an autonomous system. Like companies like Airtel and all, they can have a number of routers, correct? But when the routing information will travel from R1 to R100 or R1000, that will take up time. That is going to take a amount of time. So what we do that for faster conversions, we will just divide that particular autonomous system. Let's say I have an autonomous system here. This is my autonomous system. In this autonomous system, I might be having a number of routers. Okay, like this. Randomly, I might be having a number of routers. So now what? What I can do is I can say that, okay, if I will transfer the data from, let's say, R1 to some R1000 or R100, the information has to travel through, multiple routers. That will take a long time. So rather than that, what I can do is I can go and divide this thing into smaller parts. These are part of one. Let's say these are part of one. This is again one part. Okay. This is, let's say, again one part. And let's say these are in one part. Something like this. Now what? The routers within an area, they will have information about that area only. If they want to reach any other area, so to connect two different areas, we have a router in between where you have multiple areas configured. So this router will also be connected to something called as area 0. So to that backbone concept, I'll come on later. As of now, what you need to understand that this router will be responsible for transferring the packets from one area to another area. Okay. So these routers, they will have information about themselves only. And if they want to reach any other network, they will have information about this router. They know that, okay, this is the guy who is going to provide me communication for other networks. Understood? So let's say there is any change on this side. Now these people, they know that, okay, whenever they want to reach this side, they just need to connect this person. They don't care whether this side is down or up. They know that, okay, we are connected with this guy. That means if there is any change that doesn't have to flood through all the routers. Only these routers need to know because this guy is still up. So for faster convergence, of following, OSPF divided the autonomous system into smaller parts. Is that clear? So your OSPF works on area concept. So what do I mean when I say OSPF works on area concept? Note down that OSPF divides an autonomous system into smaller parts known as areas. Why? For faster convergence. For faster convergence. And what do you mean by convergence? How much time it takes for a router, or how much time it takes for a routing information to reach from one router to another. That is convergence. Right now, one router wants to connect with the so this guy will send, let's say, if he wants to connect here, so he will send the traffic to this person. Now he is not worried about, how to reach this guy. I know how to reach this guy. Now this guy will be taking care of everything else. Okay. This person here, this router here, which we generally call it as area border router, ABR, this will be responsible for providing communication. This will be responsible for bringing all the routes here. So whenever we will learn routes, we will learn routes through this guy. Understood? Our routing is not a part of any particular. So router between them. Yes, it's part of both the areas. Border, part of both sides. The number of routers will change. Cause, my cost, I'm talking about money, so money will increase. Right. So like each area, like between each area, there should be a change. Between each area? In each area, there should be a router connection. Yeah. So that will make like increase in. So bandwidth is not for the router, for the link. Bandwidth is for the link. So that will not increase. Is that clear? And see here. In OSPF, area 0 has you can say spatial power, or you can say significance. Okay. It is also known as, what it is known as, backbone area. Okay. Now why? Two OSPF areas cannot communicate if they are not physically or virtually connected to area 0. If two OSPF areas want to communicate with each other, then either physically or virtually they have to be connected to area 0. Is that clear? That means what I'm trying to say here is, let's say I have few routers. Take example of 3 routers. They are connected to each other. R1, R2, R3. This is one area. Remember, an area is not a router. Okay. And this is another area. Consider this is area 1. This is area 2. Right? So this is the router where both the areas are configured. Now understand, R1 will not communicate with R3. Even if, let's say, you are using the network here, 12.0/24. And this side you are using the network. Okay. Say you have the IP addresses 12.1 here, 12.2 here. Then 23.2 here, 23.3 here. R1 will not communicate with R3. If you configure OSPF here, so R1 will not communicate with R3. Is that clear? That means, let's say, for example, I have a loopback this side. Okay. 3.3.3.3. Okay. So R1 will not be able to ping this loopback. Why? Not a part of area 1. R3 will not be able to ping R1. Not a part of area. Even though they are directly connected, still they will not communicate. Why they will not communicate? Because these are two different areas and they are not connected to area 0. Clear? So two different areas in OSPF are not going to communicate if they are not physically or virtually connected to area 0. Okay. So you can say area 0 allows communication between different areas. Clear? Now, in the same scenario, note it down, then I'll see. Area. An area is a group of routers that OSPF, see, you can decide it, say it like this, that OSPF, what it does is, it divides a large autonomous system into smaller parts, which is known as an area. Why? For faster conversions. Okay. Now, these two areas are not communicating right now, but imagine what I do is I create a loopback on R2. Okay. I configure a loopback on R2, let's say something like 2.2.2.2. And this loopback, if I advertise it in area 0, okay, let's say I will advertise this one in the area 0. Now they are connected. As soon as I'll do this, automatically they'll start communicating. Automatically, your R1 will start communicating with R3. Why? Because once this guy R2 configures area 0, this guy will become something called as ABR, area border. Okay. R2 will be known as ABR. But before this, before you configure area 0, R2 is not the ABR. Any router where you configure more than one area is not the ABR. But a router who has at least one of its interface in the area 0 is the ABR. Clear? Online people clear? A router that has at least one of its interface in area 0 is an ABR. Okay. Online people clear?
Yes, sir.
Yes. Okay, you can note it down. Sorry? Either physically or virtually. Either physically or virtually. So I have configured area 0 on R2. That is a physical connection. Logical connection, virtual connection, we'll come to it later when we study about multi-area. So any router that has one of its interface, or you can say that has at least one of its interface, is known as ABR. Yes, if you configure it.
At that moment, R1 can communicate with R2.
Who?
If
No.
R1 has an like area 0 interface,
Let's say, for example, you are telling me that what if I configure area 0 on R1, right? This is what you're trying to say. So in that scenario, what will happen? See, say you have a loopback here on that one. And let's say here we have 192.168.12.0/24. Here we have 192.168.23.0/24. And here I have 3.3.3. Okay. Now consider this thing. Let's say you are telling that what if area 0 is configured here, right? So let's say this is area 0. Then you have area 1. 1. This is area 1. 12.1, 12.2. Then let's say you have area 3, sorry, area 2. This one is 23.2. And this one is 23. And still R1 will not be able to communicate with R. Why? Because your area 1 is connected to area 0, but is your area 2 connected to area 0? No. Area 2 is not connected to area 0. And area 0 is the transit area. That means if any routing information has to pass from one area to another area, it has to go through area 0. So R2 cannot share any routing information to the area 0. Same way, area 0 cannot share any information to the
Part of the area 1.
R3. Yes. If R3 was part of area 1 only, in that case, they would have the communication.
So in the example situation like R2 is area 0.
Hmm.
One loop back in the area 0.
Now, both areas you see, on R2 itself, all three areas are there.
Similarly, here if we make R2 again as well, we'll have communication.
So you are trying to say, what if I have more than one area 0?
Okay.
You can have it.
That time,
But this is not suggested, having more than one area 0. You can configure here also. Area 0, if you want to configure, you can configure here as well. And they will start having communication. But this is not suggested. Why? Because this will cause inconsistencies in your network. Multiple area zeros are not really suggested in the network. You try to keep only one area as a area 0. If you want that, okay, these guys should connect. So in that case, what you can do is you can use some concept that we will study later. It is known as virtual link. So with the help of virtual link, right now, what is the boundary of area 0? Only until here. So we will configure a virtual link between R1 and R3, between here and here. Between these two, we will configure a virtual link. This is not a physical cable, okay? This is a virtual link. This is something that we will configure. As soon as we configure virtual link between R1 and R2, automatically your area 0 boundary will increase until here. Kind of, you can say this guy has a power in his home. This guy is not having, so this guy is giving a connection to him. Similar kind of one. Is that clear? So that means now area 0 boundary increased until R2. R2 is part of area 2 also. Area 2 will start having communication. Understood? Online people clear?
Yes, sir.
Yes.
Okay. So now understood about area? Clear? Okay. Next thing we need to understand. What is the metric used by OSPF? Host metric. So OSPF uses host metric to calculate the best routes. Okay. Or to prefer a route. As many as you want. Hmm? No limitation. Okay. Now, the cost matrix depends on bandwidth. The cost matrix depends on bandwidth. And how do you calculate cost? Cost equals to reference bandwidth divided by interface bandwidth. Reference bandwidth divided by interface bandwidth. Where reference bandwidth equals to what is the value of reference bandwidth? 10 to power 8 watt. 10 to the power 8 megabits per second. Imagine that value. What is the reference bandwidth? Google it. I told you to do some research and research. I remember. Today I'm teaching you something 3 days holiday, you will forget everything. Tomorrow is holiday, Saturday we don't have session, Sunday we don't have session. After 3 days, you'll come completely wiped up. You don't remember yesterday's task. Reference bandwidth 100 megabits per second. Okay, so this is 100 Mbps. Correct? This is how you calculate. Okay. Then next is there was one point. You will see. Before that, what is the maximum hop count limit for OSPF? There is no hop count limit. Okay, so you'll say OSPF does not have a hop count limit. Okay, so it's not like you can use it in a small net. This is clear. Next point. OSPF will form neighbor relationship with other routers in the same area. Okay, in the same area. Next, OSPF does not advertise distance. Instead, it advertises the state of the links using link state advertisements. Link state advertisement. So in case of OSPF, the routing update is known as link state advertisements. Okay. Now, since OSPF is advertising the link state advertisements, so does not advertise distance within the same area. How many types of LSAs are there? Hmm? 7 types. Task types of LSA. Next one, task written types of LSA. I hope on Monday you'll remember the task. Okay. So OSPF does not send periodic updates. It sends triggered updates. OSPF includes only the change in the updates, right? But additionally, the LSAs are refreshed every 30 minutes. By default, it will send triggered update only, but it will also refresh the LSAs every 30 minutes to keep track of the information that, okay, everything is working fine. This is clear? Understood? Okay. Now your OSPF forms 3 tables again. OSPF forms 3 tables. What are those? Number 1, neighbor table. Number 2, topology here known as database. Number 3 is routing. Clear? Neighbor table contains the list of neighboring routers, contains the LSAs. Routing table contains the list of. Okay, not down. Okay, note down these OSPF messages. Next one is OSPF message. Note it down. Unmute. Guys, check now. Am I audible?
Yes, sir.
Okay. So initially the state is down. Then once the hello message is sent, the state will change to init. Okay. And once two-way communication has been established, so in that case, the state will change to two-way. And in the two-way state, they will decide that, okay, who will become the DR, who will become the BDR. Once DR BDR election is done, after that, they will start exchanging what messages? They will start exchanging the database description messages. But they will say that, okay, who will start exchanging the database first? Who will start exchanging the database information? R1 will say, I don't know who will send. R2 will say, I don't know who will send. So they will say, okay, let's decide about this also, that who will exchange the database information first. So what they will do, they will send this database description message. They will exchange this database description message, but only empty. There will be no information. These database description will be empty. That means they will have kind of information like router ID and all. No database information. Okay, these are empty. They will decide that, okay, who will become the DR, who will become the master, who will become the slave. So here that election happens, that election we call it as a master slave election. Here a process happens, what we know it as a master slave election. So the state where they are exchanging the empty database description, they are not actually exchanging the database. They are just preparing so that they can start database exchange. So since they are preparing, they are in the X start. That means exchange start. So they are preparing to exchange the database. Both have changed, right? After that, once they have decided that, okay, who will become master and who will become slave. So highest router ID will become the master. That means, say, for example, R2 will become master. Then after they will start exchanging the database information. Okay. That means R1, like R2 will share the database to R1 and R1 will share the database to R2. Like this, they will exchange the database information. Done. Let's say they have exchanged the databases. So when the actual database exchange is going on, the state will be what? Exchange. Once they have exchanged the database, now it's time that they will complete the information. They will try to complete the missing information. Maybe R1 requires more information about a particular route or R2 requires more information about a particular route. That means this is the time when they will start exchanging what? The link state request and update messages. Okay. So here they will exchange what? The link state request and update. This guy will send a request. This guy will send an update. Then this guy will send an acknowledgement that, okay, I received your update. Same way, this guy will send a request. This guy will send an update. This guy will send an acknowledgement. Then R2 will send a request. R1 will send an update. R2 will send an acknowledgement. Like this, they will exchange that information. Once the databases are fully synchronized, then the state will finally go to full. Okay, so when they are exchanging this LSR LSU, they are in the loading state. And when the databases are fully synchronized, they are in the full state. Clear? So how many? Times? That is not fixed. That will be based on how much information they are missing or what information they need to synchronize. So this is not fixed. Sometimes it will happen in one also, sometimes it will happen in 10 also. So it's not fixed. It will be based on the number of networks, number of information required. R1 will ask information from the information he received from R2 only. The database they have exchanged, right? So he will ask the information from that part only. Clear? Then after any time there is a change, let's say this loopback goes down, let's say for example. So R2 will intentionally send an update then. R1 will not ask. It's not like AGRP that I will ask you that, okay, is there any route? No. Here that mechanism is not there. There is no query mechanism here. Here directly update. that okay, this route is down, remove it from the routing table. That's it. Clear? Okay. I was looking for a table for better explanation. Better explanation means that you can note down. So let me check. I think the
Levels will be DR, data.
yes.
It will also be empty.
Sorry.
It will also be empty.
Yeah. In the X start state, it will be empty, and in the exchange state, it will be information, the database information. So you can note down this for states. Attempt state, this will be only present in the non-broadcast networks. If you have a non-broadcasting network, there only you will see the attempt state, otherwise you will not see. Okay. So overall, you have 7 states, but in case of non-broadcasting, you will have 8. So note it down. Okay, about the neighborship states. Hmm? That will be based on network types. So when we'll study about network types, there you'll understand. In non-broadcast networks, your neighbors are not automatically discovered. You have to manually configure the neighbors. It's not like you configure OSPF, they will automatically discover the neighbors and exchange the routes. No, you have to manually configure it. Okay, so note it down.
Maybe multi-cast
Hmm?
like 20 rounds, it uses multi-cast. One non-broadcast. Even non-broadcast multi-access devices doesn't have like multi-cast.
Hmm? Non-broadcast means they do not support broadcast. These equals that network type. So this will be a link type. It will come in further part. So wait for it. Right now it will be a bit confusing because we haven't discussed the area types. We have BMA, NBMA, then we have NSSA. Okay, total NSSA, point to multi-point, then point to multi-point broadcast, point to multi-point non-broadcast. Wait for it. Okay. Any other state you have a doubt? Hmm? When the hello packet contains? If R2 is sending hello packet, so R2 will have the router ID of R2 only. R1 will have router ID of R1 only. Hmm. They will have their own router ID only, not neighbor's ID. That is in the BGP. That is BGP neighborship criteria. Okay. In the BGP keep alive message and all, we have this kind of things. In OSPF also, we have some neighborship criteria. Got it? Hmm? No, no, no. If two routers are there, both routers are DR BDR also, they will elect master slave also.
But they will have the, like, DR has the highest priority by default. So it will be the master. So why are we in the election?
The election will still happen. That who will start exchanging the route? DR BDR is once you have formed the neighborship. After that, this rule is there. But right now, you haven't even exchanged the databases. It's like, let's say we are communicating. Okay, I got to know about that. Okay, you are superior. But why should I share my information to you first? Right? For that also, we need to agree. And actually, what happens once master slave election is done? After that, always master is only sending the, you can say the database. Slave cannot start sending. Okay. So what will happen? Master will send a database, slave will respond to it. Yes, it's on database. So let's say master is sending database and master information is already finished here. Whatever master database information master router has to send. So master information is finished, but slave still has something to send. So what slave will say to master? That I still have some information I need to send you, but without sending master's database, this guy cannot send. So what will happen at the end? Master will start sending empty databases. And in response, slave will send the database information. That is so technical. You have to go to CCI level for that. Hmm? Router ID. First only in the hello message itself. In the hello message, only router ID information will be there. If you take a look at our example, right? This example, see, they are including the router ID in the hello message itself. Okay. Note it. Hmm? Highest router ID. Highest router ID will become the master. Note it. Okay. Now write down the task. So first of all, packet types. Although we have discussed, you have to check it again. Okay. Then neighborship states. Then neighborship criteria. Area types. Network types. Only this much task. Then this is it for the day. Okay. Will not cover too much because in 3 days you'll forget. Online people, any doubt?
No, sir.
All right, guys, then this is it for the day. I'll see you guys on Monday. Have a great weekend and happy Holi.